So this, I think, is actually a reasonably complete mempool analysis without going too far into the details of exactly how mempool implements what it does. Um, and also it doesn't deal with how mempool decides what remotes to sync to. So P2P, it's not doesn't focus on that. Instead, it kind of focuses on major abstractions, and it was actually less scary than I thought. Um, so this shouldn't take very long, and we can just kind of go straight through it. The main thing is that there's a type called mempool backend, which is a function dictionary. Um, Probably could be a type class, um, but you know, all those usual bike sheds and caveats apply. It's the primary extraction service for Mempool. Um, and then the only other kind of main abstraction is this thing called Mempool Access that Pack Service uses, which is basically a facade to Mempool, and it's not clear why we need it. It might have types that are a little more amenable to Pact. But we'll see how that gets you. I didn't bother to indicate Mempool access in this description simply because, again, it's basically just a facade. The next thing is the main implementations. At one point, there was a notion that we were going to have a disk caching mempool. And we decided to just go with an in-memory one, which simplifies things because we really only have to maintain one code base. And it's the main work-performing mempool in the sense it's the main one that actually implements a mempool, a concrete mempool. There's another mempool backend implementation that's offered by the REST API client to give an abstraction to the client to pretend like you're just working with another mempool. And this is used in sync. So sync, in quotes, is basically a forever do loop. It's a loop that just runs forever that's kicked off when mempools are started, and basically just calls this big nasty function in mempool. But it's pretty straightforward what it does, and it uses basically local, which is an in-mem implementation of mempool backend, and it uses this REST API client implementation of mempool backend so that you're calling the same functions, and it actually makes the code pretty easy to understand. The thing that's funny about it is that, of course, that it only covers those functions that are relevant to sync. So there's out of like 10 or so functions, there's only 4 that are implemented in mempool backend for a client. So that's something maybe we could look at in terms of a cleanup later, is kind of have our sync client and then have our kind of internal facing mempool API. But for now, it's all one big thing, and there's a bunch of unsupported operations in the mempool backend for the client. But in general, if you're looking for code, you go to in-mem, with the sole exception of sync, which is actually in the main chainweb mempool class that declares the mempool backend. And it's just a big nasty function. So one of the things about mempool is that it's abstracted over a type. So as opposed to being built around pack command, it's built around this transaction config. And this is something that just provides some indirection and in theory makes testing easier. There is a mock mempool that uses a mock object for this. So as we start digging into this API, Mempool TixConfig is the one that I don't really deal with in the diagram because it's just accessors to like encoders and decoders and static things like that. So, and in most cases, it's used internally in the implementations and passed around in the implementation. So the idea that it's in the API is, something that probably could just be injected. It's not really, it's maybe not necessary that it exposes it out, but it doesn't hurt anything on the other hand. So this is a less interesting part for our discussion. So mempool member, before I dive into this, and these are in the order declared in code in this document. But now is a good time to go to the diagram so that we can start seeing some idea of what interactions there are. So mempool basically interacts with 3 services and 2 kind of pseudo services. The main kind of concrete services that mempool interacts with is pack service and the packed API. It also interacts with 1 or more remote mempools, but that all happens via this kind of pseudo service called sync. And since that's not really a service, but just a function that loops itself, that's why I have it in parentheses. As sync really comes down to a subset of the API calls. And then there's another pseudo service called Mempool Consensus, which is really, it's also basically a function that gets kicked off by pack service. I believe we do it after new block. And it's basically, since new block is the first time where we basically guess that, well, if there's a fork, the first place we'll see it is a new block. So new block kicks off this, and new block, so it kicks off this thing called Mempool Consensus, which is basically looking at consensus and working with pack to try to figure out what transactions may need to be reinserted into the mempool because they got forked away. So that's the other pseudo service. But returning to sync and the 2 mempools, there's really 3 functions, 3 functionalities, capabilities that are how they interact, and that's insert, lookup, and get pending. And the sync operation is basically one that can insert into the local mempool, can insert into the remote mempool, can look up transactions in the local and remote, and kind of kicks off with this get pending call. So let's recall what a mempool is for. A mempool is for, well, if we, actually, maybe we can just do a gloss over this first. So those are functions that are used by the 2 mempool clients by a remote and a local to stay in sync. So that's both push and publish, as well as get stuff from other nodes out there and try to keep all our mempools roughly in sync. The other main service here is another main service here is packed API, and it's really interacts with mempool and only 2 of its endpoints, and that's send and pull. So send is the main entry point for packed transactions, and it wants to do this mempool insert check, which is part of the kind of internal mempool API, and it also wants to do, once it succeeds, it does a full-on insert. So this is the one place where insert gets called, by the public or whatever. So that's where insert is, the real front door to insert is send. And then pull does a bunch of stuff, mainly with pack service, but it also needs to know, there's some edge cases where it needs to know if a transaction failed, and we'll get more into that in a second. And finally, pack service needs mempool, most obviously for new block, because it wants to call mempool get block and get a bunch of transactions. but it also wants to handle failures at that point, so it's got special access to this bad list concept. And then Mempool Consensus, since it's examining consensus to see if there's forks, which would mean that transactions that we thought were executed weren't, its job is to reinsert transactions into Mempool. So that's the kind of around the world. So recalling what a mempool is supposed to do is it's supposed to accept transactions from the world, which is via the Pact API, and then it's supposed to hold on to them until such time as they can be included in a block. And it's got a fitness function for deciding, for sorting and basically saying which transactions have higher priority. That's all part of its internal implementation, though. And then it needs to maintain a little state machine for each one where a transaction that has been accepted but not passed into a block yet, and indeed I think not validated yet, although it might be, I can't remember if it has a state after new block, but again, that's an implementation detail. But the most important states for the kind of larger system are basically pending and validated, and also bad or rejected. So keep that in mind. The mempool is basically holding on to a body of transactions. The main kind of live transaction is considered pending. A validated transaction is basically one that finished, quote unquote, successfully. And a rejected one is something that it keeps track of to give feedback to the user that their transaction failed and did not make it into a block. Okay, so with that, we can kind of look again at sync. And so the idea is what sync is doing. Sync kicks off with get pending. So if we go look at that, get pending uses the notion of a high water mark. And so what it's basically trying to do is a synchronizing get or an as of get to get all pending transactions that it hasn't seen before in bulk. And this is basically what the first thing sync does is get pendings from the remote and call get pending on itself, and then start a process by which it tries to see if those are in sync. And the way it does that is to look it up. So, which is a little bit redundant. I think it first tries to reconcile those lists, and then it also does lookup. And lookup is, note that these have gotten pending. So these should all be pending transactions coming through. But since there are transactions that have come in from remote that you might not know, or that might be in a different state in your local mempool than the remote mempool, the next thing to do is do a lookup, because a lookup will give you this lookup result. And one of the things a lookup result will basically tell you, well, one, if you found it at all, and then you can check to see if it's in some different state and needs to be synchronized back to the remote. And that has to happen bidirectionally. So there'll be lookups on the remote, there'll be lookups on local. And once you have an idea of the changes that need to be made, you do an insert, because insert can basically insert functions as update state as well, kind of like in Haskell maps. There's no update, you just reinsert. Obviously, the front door it takes steps to make sure that, I'm not sure whether it rejects on dupes or if it just doesn't care. There's obviously something to prevent. I mean, these are all the data structures are guarded by the transaction hash. So you can't have a duplicate hash in the mempool. So if you insert, you're basically updating state. So for instance, if the remote mempool sent you a transaction that was in pending, but you validated it, you would look it up on your local and then actually call insert on the remote to directly update the remote for. So as you can see, there's this thing called lookup, and then looking at insert. Yeah, and all of these work in bulk. So insert is the function that gets called both on remote. It's also worth noting that Rosetta now has need for some of these things. So Rosetta is calling these directly. This is something we may want to review later, because while this one's probably fine because insert is an API call, Rosetta also uses this kind of private function. Well, we'll get to it later, but we'll come back to an issue with Rosetta there. But so Rosetta uses insert as well, and so insofar as there's an API call for that, that could be okay, kind of going forward. But we might want to return to that. So that the other thing that is in the remote and local, or correction, the other thing that is in the APIs, because what gets exposed in the APIs kind of forms the public interface, is this member function. But what's interesting is that member is never used in our code remotely. It's only used in sync. It's only used as part of a check against, I think, get pendings or lookups that it's done on the remote. So, it's a question whether or not we actually need to expose this. But maybe it's useful. But I'm of the opinion we probably shouldn't expose any more than we have to. So that's something we could consider for removal, because it's only used against. It's only used when it says against a remote collection. It means it's gotten a remote collection of hashes and it's going to use member to test if it's in our mempool before it does anything else. Right, and mempool lookup is documented to say that it's getting pending, although I'm not positive about that. I think this comment might be old. I think it might have to filter. Yeah, and in all the code that uses this, you'll see. So lookup is, kind of used as this kind of directed fetch function where you can give it hashes and get the particular transactions you're looking for. And it will then query them to see if they're pending. So it'll do grab from remote and insert to local if they're pending, but it does do a filter, and it'll grab from local and push to remote if it's pending. So I think this comment is probably wrong. It's probably just lookup transactions in the queue. So I think we've covered all the kind of public sync-oriented endpoints. So now I'm just going to go down this list and then where it takes us in the diagram. So we talked about member, we talked about lookup, we talked about insert. The other places where insert is used, as we've mentioned, is that it is used in send, and that is the main front door to the mempool. The other place is, it's the only thing we can talk about mempool consensus now. So as I said before, Mempool Consensus is basically kicked off by packed service at the end of new block, because that's our best guess when we think a fork might have showed up. And basically, again, what it does is it looks at the current fork, it looks at the previous fork using cutDB, and then queries checkpointer to see any transactions that have been removed, and then reinserts those. So that's why it's the other service that will actually result in mempool insertion. And this is a pretty critically important function, obviously, because otherwise it would mean that if the blockchain gets forked, you would have to resend your transaction. And no blockchain does this. The Satoshi white paper famously says that the great thing about blockchain is that mempool does not need to be a transactional service. That's one of the great simplicities of Bitcoin. But in practice, the client would have a terrible experience if they have to resubmit a transaction every time there's a fork. So mempool ends up being a pseudo transactional service and has to do quite a bit of interaction with consensus and what transactions got played. And of course, this could be done on demand, but that would probably be quite slow. and quite expensive. So instead, what we do is we pick the best time we can think of to see if there's a fork, and then try to do all the reinserts at that time.
One thing, Stuart, I think we didn't used to have that, and because normally we would say, hey, every time you do a validation or you go do a new block, you would, or every time you do a new block, you do the rewind and you would see that. But the problem was that if your node is not mining, there will never be a new block call, but you still might have a mempool. I think this mempool consensus essentially kicks in or compensates for a situation where you don't get new block calls. Is this correct?
No, not to my understanding. My understanding is that Mempool Consensus is explicitly kicked off by new block.
Oh, interesting. So maybe I have to look at that again, because I think there was a time when we said
well, remember, you have to assume that somebody's mining. So insert kicks off, insert affects sync. So if transactions need to be reinserted because a previous sync had eliminated them, so even your idle mempool will get resynchronized from the remote. So somebody has to do it, but it doesn't have to be the non-mining node. Basically is at the mercy of other nodes sync to push these kinds of reintroductions to them. Also, I mean, that's an important thing actually, is that that's actually a good point. So thanks for bringing that up, because one of the things that's interesting is that there's this thing called mempool prune. And mempool prune, I was kind of scratching my head about, because it's only used in the no-op miner. But this must be what you're talking about, Lars, because what no-op miner does is I'm not even sure, basically prune goes through and gets rid of truly expired transactions, because I think there's a potential memory leak based on the various activities of sync and consensus, such that those transactions will hang around longer than they need to if you don't call new block. So the no-op miner does this, is the only, this prune operation exists for the no-op miner.
Oh yeah, sorry. Then I confused that. Yeah, no, that's what I meant. There's some functions that kind of kicks in when there's new block. But in that case, then I'm not sure if mempool consensus actually looks at the current state of consensus. It might be that it only kind of gets informed by new block, kind of whatever the state is that new block uses, and then just
no, because new block does not have. The whole reason it has to do this is that new block does not have that information. Yeah, so it has to call cutDB.
But yeah, but it might only get from the cutDB essentially the pass and the information for what the rewind is. But I don't
absolutely.
I don't think.
No, that's right. No, you're right. Yeah. That's correct. And then everything else is interacting with back service and checkpointer.
I think it doesn't query the current cut, because normally there would be a problem if normally
it's probably the cut that new block is looking at.
Yeah, exactly. Okay, yeah, that's it. Because we used to have an issue there, when we had races, because PacDB Pact has only exactly one state of its view of the world. And if new block is sitting on one, the current cut might be a different one. And we used to have races. But I think now Mempool Consensus uses whatever cut is new block using, and then asks the cutDB for the rewind pass or what transaction that needs to insert in.
Yeah.
Yeah. Okay.
All right. So those are, again, so we're kind of done with the main kind of external things. So now we're just going down the list. So mempool insert check is another internal but important mempool function. And what it's used for is kind of fast failing in send. So we want to make best efforts when a transaction comes in to reject it as soon as possible. And so we have this function called mempool insert check, which in turn, again, we're not getting into implementation details here, but in turn, mempool insert check will do a bunch of static checks that are, relevant to the mempool itself. It'll make sure that the time isn't in the future. It'll make sure the TTL hasn't expired. Lots of things like that. But it also wants to make sure that you're a valid user of, namely the sender, and that you can buy gas and all those kinds of things. And so it calls pre-insert check on pack service as well, as kind of a dirty read to see if this sender's in a bad state. And if the sender's in a bad state, so that's a good UX for the user, because it means that you'll immediately get a rejection if you have something just wrong with your gas configuration or something like that. So this, by the way, is the function that's used in Rosetta the construction functions in Rosetta, because they're always a pair. You always, as you can see here in send, it does insert check and then it does insert. They're a pair. So Rosetta needs to do this too. So I think one of the things we want to look at is maybe making, at some point, Rosetta use something closer to send and not directly hit the mempool. But that's not something I want to worry about right now. But maybe, Linda, you can track that. Anyway, so it's a fairly straightforward thing, though. It's basically going to find an insert error if something's wrong and kick it out, and then otherwise it's going to call insert on everything else. So there's a pair of transactions that form part of the internal interface that have to do with how pack service interacts with the mempool. So the first thing is that when pack validates a block, that means that, you know, we're done with these transactions. They've been validated. They're going to go into our databases. They're going to go into the check pointer. So at that point, we also let the mempool know these transactions have been executed, so mark them as such. And, you know, that would presumably that they'll get gossiped out at that point as validated. And, you know, in that way, the entire system will eventually be aware that these transactions, you know, successfully executed. And that's also important for poll, because that's how poll will be able to, poll will know to go ahead and grab the results from, you know, initiate the process to grab the actual command result and give that back to you. So this is basically to maintain the state machine once a transaction is validated. And you can see it here that in pack service validate, it calls mempool mark validated. So now we have this notion of a bad list, which I wanted to dive into just a little bit more. The bad list is how mempool tries mightily with the insert check to have nothing but good transactions. However, that's a dirty read, and state can change. In fact, we even do in new block. We'll talk about that in a second. But the point is that there are cases where once a transaction has been accepted, it can still be an invalid transaction. And as a reminder, a pack transaction that fails, as in it fails in the pack code, is not a failure as far as Chainweb is concerned, because we want to make sure that that transaction gets charged full gas, because otherwise people would send in garbage transactions and DOS us. And this is a problem in Ethereum and every place else. So there's this pattern that says that kind of a user level failure just results in consuming all gas. And, you know, don't fuck up next time. But that's otherwise considered a success. So a bad is basically when someone, either there's some problem with the envelope or somebody wasn't able to pay for gas. And that's really what the bad list is for, because before they would just kind of disappear. And so the bad list is there so that you do, well, one, so that you can push that around, gossip it, and not have this transaction be reintroduced over and over again, but two, also to give feedback. So the kind of important related function is mempool check bad list. So first, in our diagram, one of the places this is used is in poll. So it's going to check, in addition to checking, you know, in addition to, well, that's actually all poll cares about, because everything else it's going to find from the check pointer store of completed transactions. So it's going to find any that are in the bad list, and it's going to union those with any successes that it actually doesn't even bother with mempool to get. But the places where it's added to the bad list via this call is in new block, because what happens is new block does another kind of best effort. Before it runs the block, it just runs the buy gas portion of the block to see if there's any senders that can't pay for gas. And at that point, it wants to add those to the mempool. So that's why it calls mempool add to bad list. But this is all part of the big call, which is mempool get block. That's really the main thing. This is the big business function that's going on in new block. Is new block wants to and there's a weird indirection here. One of the things that you'll note here is that mempool doesn't, the only thing that mempool depends on is other mempools. And it doesn't even directly depend on them, it depends on them via sync. So mempool is decoupled from every other component. But however, there is a knot that needs to be tied there. And that's why there's this thing called mempool pre-block check, which is a callback back to pack service to do this like pre-gas check, to do this kind of final check to make sure that these transactions are okay to actually go into a block. And it's inside that callback where the call to add to bad list happens. So while on this it's new block and it shows new block calling add to bad list, it's actually really more like new block, call this weird lambda that calls add to bad list, and then come back from new block with your new transactions. Not positive this is the greatest design, but it does preserve mempool being not having any kind of dependencies. So, choose your poison, I guess is what it is. So yeah, this is kind of the big function. Obviously, this is not implemented by remote. And mempool prune we've already discussed. Mempool getting pending transactions we've already discussed. And the only other function is mempool clear. And that's only used in testing so that you can reuse a mempool in a test. That's it.